Why data citation is a computational problem. First of all, I'd like to introduce our topic. You have traveled the road to knowledge. Can you find that road again? So references show the way to find it again, but they traditionally point the other academic papers. What about when understanding comes from databases instead? Most information is now published in complex, structured, evolving databases. Because today, the world is digital. More and more scientific information is found in digital databases. This change affects how we receive and communicate references. There are large of parts of databases, and there are infinite numbers of queries that could be asked to get the information out of the database. There is more and more demand that this digital information should be treated in the same way as conventional publication and be appropriately cited. So the problem is databases citation is a challenge because of the structure and evolution of databases. There is a problem of citations failing to credit original researchers. The content of these databases are in generally by people, and to some extent, people are doing it for free because there are numbers of scientific community and they see a benefit to sharing that information. But remember, unless they start getting credit, they may be less willing to contribute. Well, principles and standards have been developed for data citation. They are unlikely to be used unless we can couple the process of extracting information from the database with that of providing a citation for it. So, if we expect people to cite digital data, simply providing principles and standards for citation is not enough. We have to also generate the citations. So now I'd like to move to two sample scientific data set. First is GTube. GTube is guide to pharmacological databases. Is a major feature of current biological science is the creation and curation of databases documenting the genome, proteins, and phenotypes and their interlinkage. Pharmacology increasingly uses molecules and techniques that rely on these databases but has not been effective, particularly in publications, in linking in the pharmacological data, especially functional information on drug targets and the drug that act upon them. There is also a perceived need for nomenclature standards, without which linkage between databases become impossible. This is now all possible by employing GTube, an expert-driven guide to pharmacological targets and the substances that act on them. GTube can therefore be thought of as a structured hierarchy. Major strengths are the classification of all human genome encode drug targets and nomenclature thereof, and the inclusion of functional pharmacological data in which other databases are very deficient. By linking drug targets and ligands to GTube, journal readers can link the other databases and place the work in the paper firmly in the context of the greater world of current knowledge as contained in these databases. Second, I'll introduce the MODIS. MODIS is moderate resolution images spectrometer. Some data comes not from the researchers but from devices like satellites. MODIS is an electromechanical optical imaging system currently flying aboard NASA's satellites. The many data products derives from MODIS observations describe features of the land, oceans, and the atmosphere that can be used for studies of processing and trends on local to global scales. So in this case, MODIS products are available from several sources. The scientists wants to be able to give credit to or acknowledge the tales, the sets of information during a particular scan of the Earth. So I will give the rest of our topic to my partner, and he will show the rest of the presentation.
Hello, my name is Cheng. In this presentation, I'm going to talk about some solution. The first, I will show this figure. The figure represents the G-tube and the hierarchy, which is how it is published on the web page and understood by the many contributors and users. And we can see there are 4 different classes nodes. In the high level of the hierarchy have citation with collaborators, the editors and the such as the Hammer, Sharma, and Miller. And the low level with the contributors is a Miller, Drucker, or Salvatore, maybe. Suppose we have a database schedule S, a venue V over S, and a query Q. If Q can express the query over V, then the citation show it with V is the candidate citation for the Q. So it is the formula for the 1V. If there's two more, the formula is just like this one. And the next part, I will introduce the more detail about the G-tube. Here is the first is some owner find the different type of the citation, the family view, and the introduction view and the target view. And the next part is the creating template for the each types. And then is a researchers create the citation. And here in the G-tube there are 3 classes of venue. Not just like this. The one is the family page, one is the family introduction venue, one is the target venue. Follow the rule. The right hand side of the rule is the express like expansion that contains 2 color variable. The X variable are the venue parameters, and another variable are bound once the X variable has been matched. Here the contribute, which depends the family as the version number. Let's use this Concordia for example. It also the citation for a simple SQL selection on the family table with name Cotonia. Maybe this SQL is clear above. In this case, it's again easy to determine that it can be answered using the appreciate relationary vision of the family view. And the next part is the models. The first is the spatio-temporal query. This reflects the retrieval capabilities of many models product distribution systems. The next part is the parameters. This describes the common bounding box retrieval patterns. And then it's a citation ruler for the models. The first, and you can see the M author is a faction that given a product and a version and query the metadata for the authorship. And to our knowledge, this is currently not such organized metadata repository in models, but having one would clearly be beneficial. The version and access time, the data faction, are also not part of the venue definition, but can be calculated when the query is executed. Note that in the models, when neural analysis software become available, the entire database or product is reanalyzed using a complete new version. Old versions are not kept well. This understandable from the standpoint of provenance and reproducibility. A citation carries useful information even though its referent may not exist. All in all, in conclusion, in this presentation, we focused on one specific computational problem. We believe that using database venue to specify citation units is the key to both specifying and generating citations. It's important for any data publishers or authors who wants that data to cite to define these venues and to ensure that the data necessary to generate the citations from them is available. We have shown in this presentation some example and some quite different statistical databases, such as and we can see the main issue of this is that the data needed to generate the citation may not be available, either in database or some metadata repository. I think the data citation in the future is going to look very different. So we could think about the citation to have 100 of authors, or perhaps 100 of citations, or the closure of citations. That's all of the influence. That's up to a particular piece of work. So that's my presentation. Thank you for watching.